Class 10 Science Chapter 2 Acids, Bases and Salts. Acid, a substance that produces hydrogen ions, H+, in aqueous solutions. For example, sulfuric acid, H2SO4, hydrochloric acid, HCl. General properties of acids, times they have a sour taste. Times they turn blue litmus to red. Times they conduct electricity in solution form. Times they release H+ ions in aqueous solution. Reactions of acids. I. Reaction of acid with metal. Na, metal, plus H2SO4, acid, gives H2, hydrogen gas, plus NaSO4, salt. 2. Reaction of acid with carbonates. Na2CO3 plus 2HCl gives to NaCl plus H2O plus CO2. 3. Reaction of acid with bicarbonates. NaHCO3 plus HCl gives NaCl plus H2O plus CO2. Base, a substance that produces hydroxide ions, OH, in aqueous solutions. For example, sodium hydroxide, NaOH, potassium hydroxide, KOH. General properties of bases, times they have a bitter taste. Times they are soapy to touch. Times they turn red litmus to blue. Times they conduct electricity in solution form. Times they release OH ions in aqueous solution. Reactions of bases. I. Reaction with metals. 2NaOH plus Zn gives Na2ZnO2 plus H2. 2. Reaction with nonmetallic oxides. 2NaOH plus CO2 gives Na2CO3 plus H2O. 3. Reaction with acids. NaOH plus HCl gives NaCl plus H2O. Strong acids. An acid which completely dissociates into its ions in aqueous solution. For example, hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3. Strong base. A base which completely dissociates into its ions in aqueous solution. For example, sodium hydroxide, NaOH, potassium hydroxide, KOH. Weak acids. An acid which does not completely dissociate into its ions in aqueous solutions. For example, acetic acid, CH3COOH, carbonic acid, H2CO3. Weak base. A base which does not completely dissociate into its ions in aqueous solution. For example, ammonium hydroxide, NH4OH. Concept of pH scale. Strength of an acid or base can be determined using a pH scale. It is a scale to measure the hydrogen ion concentration in a solution. The P stands for potence. It is a German word which means power. For water or neutral solutions, pH is equal to 7. For acidic solutions, pH 7. For basic solution, pH 7. Importance of pH in everyday life. I. pH in our digestive system. Our stomach produces hydrochloric acid that helps in the digestion of food. During indigestion, the stomach produces too much acid and this causes pain and irritation. To get rid of this pain, antacids like magnesium hydroxide, MgOH2, also known as milk of magnesia, and sodium hydrogen carbonate, baking soda, are used to neutralize excess acid. 2. Tooth decay caused by acids. bacteria present in the mouth produce acids by degradation of sugar and food particles remaining in the mouth after eating. When the pH of acid formed in the mouth falls below 5.5, tooth decaying starts. The best way to prevent this is to clean the mouth after eating food. Using toothpastes, which are generally basic, for cleaning the teeth can neutralize the excess acid and prevent tooth decay. 3. pH of soil and plant growth. Most plants require a specific pH range, close to 7, for their healthy growth. If the soil is too acidic or basic, the plants grow badly or do not grow at all. pH of the soil can be adjusted by using certain chemicals. For example, if the soil is too acidic, then it is treated with materials like quicklime or slaked lime. On the other hand, if the soil is too alkaline, then alkalinity can be reduced by adding decaying organic matter. Preparation and uses of important compounds. Caustic soda, sodium hydroxide, NaOH. Preparation. In the process of electrolytic decomposition of brine, aqueous solution of sodium chloride, brine decomposes to form sodium hydroxide. 2NaCl plus 2H2O gives 2NaOH plus Cl2 plus H2. In this process, chlorine is obtained at anode and hydrogen gas is obtained at cathode as byproducts. This whole process is known as chlor-alkali process. Uses. Sodium hydroxide is used for degreasing of metals, manufacturing of paper, soap, detergents, artificial fibers, etc. Bleaching powder, calcium oxychloride, CaOCl2. Preparation. Bleaching powder is produced by the action of chlorine on dry slaked lime, CaOH2. CaOH2 plus Cl2 gives CaOCl2 plus H2O. Uses. Bleaching powder is used I. For bleaching cotton and linen in the textile industry, for bleaching wood pulp in paper factories, and for bleaching washed clothes in laundry, 2. As an oxidizing agent in many chemical industries, and 3. To make drinking water free from germs. Baking soda, sodium hydrogen carbonate, NaHCO3. Preparation. The chemical name of the compound is sodium hydrogen carbonate, NaHCO3. It is produced by the reaction of brine with carbon dioxide and ammonia. This is known as Solvay process. NaCl plus H2O plus CO2 plus NH3 gives NH4Cl plus NaHCO3. Uses. I. Baking soda is used in making of baking powder, which is used in cooking. Baking powder is a mixture of baking soda, sodium hydrogen carbonate, and a mild edible acid such as tartaric acid. When baking powder is heated or mixed in water, the following reaction takes place. NaHCO3 plus H plus gives CO2 plus H2O plus sodium salt of acid. From any acid, carbon dioxide produced during the reaction can cause bread or cake to rise, making them soft and spongy. 2. Baking soda, sodium hydrogen carbonate, is also an ingredient in antacids. Being alkaline, it neutralizes excess acid in the stomach and provides relief. 3. It is also used in soda acid fire extinguishers. Washing soda, sodium carbonate, Na2CO3.10H2O. Preparation. Sodium carbonate is manufactured by the thermal decomposition of sodium hydrogen carbonate obtained by Solvay process. NaCl plus NH3 plus H2O plus CO2 gives NaHCO3 plus NH4Cl. NaHCO3 gives Na2CO3 plus CO2 plus H2O. Na2CO3 plus 10H2O Na2CO3. 10H2O. Uses I. Sodium carbonate, washing soda, is used in glass, soap and paper industries. 2. It is used in the manufacture of sodium compounds such as borax. 3. Sodium carbonate can be used as a cleaning agent for domestic purposes. 4. It is used for removing permanent hardness of water plaster of Paris, calcium sulfate hemihydrate, CaSO4, a half H2O. Preparation: on heating gypsum at 373 K, it loses water molecules and becomes calcium sulfate hemihydrate, CaSO4, half H2O, which is called plaster of Paris. Plaster of Paris is a white powder, and on mixing with water, it changes to gypsum once again, giving a hard solid mass. CaSO4. Half H2O plus 1 and a half H2O gives CaSO4. 2H2O.